Alright, problem 18 says circle whether the equation represents direct variation or not. Direct variation was in the form y equals kx. So we need to get y by itself here to determine if this is direct variation or not. So we have 2x plus 3y equals 6. So we'll subtract the 2x from both sides. That gives us 3y equals negative 2x plus 6. We can already tell it is not direct variation because the y-intercept is something other than 0. So the y-intercept would be 2. So this is not because of that plus 2 there. The y-intercept is 2. To be direct variation, the y-intercept must be 0. So this one was not direct variation. Alright, number 19, circle whether the equation represents direct variation or not. This one is in the form y equals kx. In this case, we could rewrite it so we can see it a little more clearly as y equals 1/3 x. There's an implied 1 up here with x. X is being multiplied by, not divided by. So yes, this one is in direct variation where the k value was equal to 1/3 right there. Alright, on 20 and 21, we want to write the linear inequality of the given graph. So we find the y-intercept on this one, number 20, that would be a negative 2, and then identify the slope. I can tell from looking at the line, plotting these points, it's going down 1, right 1, down 1, right 1. So the slope is negative 1. The y-intercept, the b value, is negative 2. So this number 20, the linear inequality, would be y and then negative x minus 2. Okay, that's the line portion right here. Now we just need to put our symbol in. We have a solid line shaded below, so that would be less than or equal to. The less than, this less than symbol, is because it is shaded below down here. And the equal to part, this portion of the inequality, is because the line is solid, it's not dashed. Alright, now let's move on to number 21. So here we have a b value right up here. B value is negative 5 right here. And then if I track back and find a point perfect ordered pair that's not a decimal, that point right there looks good. So it's down 1, 2, 3 over 1, 2, 3, 4, 5. So down 3 over 5 gives me an m, a slope, down 3 over 5, negative 3/5. So also we're shaded below and the line is dashed. So that would be y is less than negative 3/5 x, subtract 5. And that would be for that inequality. Again, let's review. Less than because we're shaded below. No equal to here. No equal to because the line is dashed. Alright, here on 22 and 23 we are still writing equations of linear inequalities. So y-intercept here is 5, so b equals 5. And then my slope, I can tell, has perfect points here. It's going down 1, right 1, down 1, right 1. So my slope is negative 1. That means my equation will be y negative x plus 5. That's the y-intercept right there. And the slope right there. Now we put the symbol in. It is solid, shaded above, so that would be greater than or equal to. Greater than because it's shaded above, that's this part. Equal to, so this line underneath, because the line is solid, it's not dashed. Okay, let's move on to 23, and we'll have the review completed. So y-intercept here is 2, so b is equal to 2. Now find the next perfect point, and that would be right here. So that's up 1, 2, 3 over 1, 2, 3, 4, 5. So up 3 over 5 gives me a slope of positive 3 over 5. Up 3 over 5. So my equation, my linear inequality I should say, is y. Put the slope in, 3/5 with x. And then the b was plus 2, positive 2. Now put the symbol in. So it's solid and shaded above. So that would be greater than or equal to, again, same as the previous problem. So that's it for the review.